So, without further ado, let's go to Remy Sharp.
Right, just give me a second while I plug it. Okay. Okay, are these supposed to both be on? Can you hear me if I talk like this?
Yeah.
Yeah? Oh, wow, okay, cool. I can do this hands-free. Okay, so this is my take on the art of debugging. It's how I debug, it's my workflow. It's what I find useful when I'm looking at new tools. There might be a few tricks in here that will be helpful to you, but it is subjective. Okay, so just bear that in mind. And I'll touch on frameworks and so on later on. I broke it down into two parts. So the first part of the talk will be kind of more theory, and the second half will be practical. But the real trick to the art of debugging is to, you don't write bugs, and that's it. Yeah. So about 45 minutes of questions. Yeah? No. Okay, maybe not. So assuming you're not all robots, you might have written a bug or two in your time, right? And there's no silver bullet. And in fact, when I say don't write bugs, I actually kind of believe in the opposite. You need bugs to give you experience to get better at what you do. The more bugs you encounter, the more variations of problems you encounter, and the more ways you learn to solve problems in kind of more creative ways, and that's how you get experience. And really the trick is learning how to identify bugs without having to spend 3 or 4 hours just kind of running through the laborious process of trying to find some typo or some semicolon or something. So, learn from your bugs. Spend time working on bugs. Use them as your challenge. There's no hard and fast skill to learning how to debug. There's no user manual on debugging. It takes hours and hours of problems. And the upshot is you won't spend hours and hours the next time that you encounter that problem. So you want to be the bug hunter. Now, the company I worked at over a decade ago now, we used to interview our employees, our potential employees, and we'll sell the business them at the same time as telling them about what the job would be about. And really kind of sell them on the kind of work they'll be working on and the problems they'll be solving and the technology they're using. They get really excited and they get the job and they come in and then we're like, right, so you're on bugs for 3 months. And that kind of just deflates them completely. They think it's a bit of a duff role. But the thing is, they then go off and work on these bugs for 3 months and they get to basically touch nearly all of the code base because they get to solve problems all across the code base. Whereas if I was working on a feature for the website, I'd be working on the same feature for 6 months. The same code, the same problem, over and over until I finally almost get it live and there's some bugs in it, and then the new guy comes along, fixes it, and they get all the praise for fixing the bugs that I spent 6 months building. And when it came to it, at the end of that period that they were working on the bugs, they actually didn't want to leave. They wanted to stay on working on bugs until we brought in someone new and they had to kind of cycle off. So I enjoy this part of the process. It makes me kind of a master of my craft. Yeah, I think the key to being a good developer is knowing how to debug pretty much anything. And I think there'll be some of you who you program in just one language, but because you understand programming and logic, you can go to another language and you can reapply that problem, that way of thinking. And the same comes to debugging. It's just problem solving in different ways. Another one of my colleagues from years ago, he was kind of the CSS guru, and this was back in the time when I had no idea about CSS, and CSS was a bit of a dark art to me. I knew that I could kind of float left and it would make something move. So I'd always go to Chris, this guy who was our CSS wizard, and I'd say, look, how do I fix this thing? And he would just have to look at my code, not even read it, but just kind of glance at it and say, oh yeah, you need zoom 1 on there. So anyone who's worked with an older version of IE knows that zoom 1 fixes a whole bunch of layout problems. And it wasn't because he was just throwing a default answer to me every time. It was because he recognized the problem in so many different shapes. He was able to quickly kind of skip past that whole large debugging process of bringing out an inspector and the old IE tools to kind of work out what's going wrong, and he could fix IE for me in just that one zoom equals 1. So he completed the debugging process with one single step. Now, the truth is, debugging should be the absolute last process in all of your development well, you'll debug as you go along, but everything that I'm covering now, if you had tests that covered all of this, you wouldn't have to debug anything, right? You write the code, or you write the test, you code to the test, it passes, and it all works out the door. Tests come long before debugging, or certainly should do. If you don't have any tests, that's how I've been coding for a long time, and it's not fun. It means you have to constantly go out and debug. So, first disclaimer is I hope you have tests, you're not just jumping to the debugging process. Now, the way that I like to debug is inside of the browser. Not on the server side, not in my tools, I use VS Code now, but Sublime or anything like that. I don't like to write code, write a change, hit save, go back to the browser and so on, and repeat this long process. But frameworks are one of the questions I quite often get when I show people the workspaces and the way I'm debugging. Now, this is a subjective talk, so I don't use frameworks that much. I started using React quite a bit, but I don't use Ember, I don't use Angular, I don't use Vue. I have started using React, and one of the pain points I have is that I don't have the same amount of the same kind of detail in debugging. I can't get as close to the problem as I want to, and it's because of this, because of the big transpile process you have. The code that you're working on is not equal to the code that's running in the browser. So here I've got a bug being thrown, and it's just dumping out this big stat trace. I'm supposed to understand, how deep inside of React this is broken. I've got no chance of following this and understanding exactly where the problem is. These frameworks are, they're really powerful, they're really impressive, but they're so complex that they've created their own languages, like JSX, it's its own language. So they have to have their own debuggers. They've gone ahead and used like in DevTools case and Firebug's DevTools, they've got their own custom debuggers to kind of attach and layer on top of their own layer of complexity. So yeah, you can get debuggers for React. This is the React DevTools. There's only one at the moment that I know about. It's pretty good, and it's getting better with time, but it's not as good as just bare metal debugging tools. This is a bit cheeky. Basically, it sounds bad, but it's not quite as bad as it looks. I don't cross-browser test a whole bunch of the JavaScript that I write because I'm writing just raw JavaScript. Right? ECMAScript works the same in every browser. If you go far enough back in time, then yeah, you'll get some oddities in like IE4 or IE6 maybe, where kind of string.indexOf doesn't exist, but we're not dealing with IE6 anymore. It's more kind of IE 10, 11, 9 maybe. ECMAScript itself, the JavaScript engine, is solid all the way through. He says. It's the rendering that have cross-browser problems. So the first part of this not cross-browser testing is I'm working with APIs that are well-defined, well-specified, and implemented exactly the same across browsers. So if I were to use a local storage API, it's exactly the same across browsers. If I use the web audio API, it's exactly the same across browsers. I can't write code that only works in one browser and not the other. The only exception there is maybe if the API doesn't exist yet in that browser, and polyfills get me most of the way there. If I want to use string.includes or any new kind of ES6 string functions, for instance, or array functions, I can use a polyfill to just pull in that function that I need, and my code works as I expect. I am working with pure JavaScript a lot of the time. Even when I am writing these React applications, or kind of just a very kind of simple bit of front end, it's just vanilla JavaScript. Like for instance, React is doing like the rendering part for you. Your JavaScript is the thing that handles all the business logic, all the logic that says go and do something with the user's input and do an XHR request and process it this way and do something with it, or image manipulation and so on. It's just pure JavaScript at that point. So it doesn't really matter where the code runs in which browser, in my humble opinion. But rendering is the place where it's completely different in every browser. Or not completely different, but there will be quirks and differences between different browsers, particularly the way it renders, the speed it renders, the priority in which it renders, and so on. Now this doesn't mean that I don't have some automated tests with things like Zool or Karma. I think cross-browser front-end testing is still a little bit difficult. I think we'll need to remove a lot of configuration that's required to be able to do it, but that's where most of my testing will go. That's where the cross-browser testing will go. But due to the nature of my particular work, I'm kind of focused in the pure JavaScript end, the APIs and the polyfills. So, with those caveats aside, this is how I open my workshops. So, the art of debugging, okay? And Wikipedia has a page on debugging, and it mentions that it's something of an art. So, we can say that debugging is actually an art, or I can say it's an art at least. So, this is my art of debugging. So the first thing is replicate, and this is the hardest part of the work, right? Saying that something works for me, saying something doesn't work for you and sending it to me and I say, oh no, it works for me, it's fine, is not debugging, it's not useful to anyone, and it basically makes developers look pretty shoddy. So never ever do, it works for me, please don't, right? This is a bad thing, okay? If it works for you, it means that there is one machine in the world where this particular thing works. It could be that every other machine doesn't work, right? So, start with a litmus test. Very simple, like, does it work on that machine? Open up an incognito window. That's one of my easy tests, jumping ahead, but if someone raises a bug with JSBin, for instance, the first thing I'll do is, so I wrote JSBin, which is why I'm using the example. First thing I'll do is visit that URL to see if I can see the bug that they're looking at. If I can't, then immediately I know that there's some extra variable that they have in their environment. That variable could be the operating system, it could be the browser, it could be an extension, it could be some other piece of code. It could be that they ran it at midnight instead of during the day. There's all these extra variables that I'm not aware of when I'm actually doing my litmus test. But the litmus test, if it fails, then that's the easiest type of replication. Be super systematic. So if I can replicate the bug, I want to make sure I can replicate it consistently, right? Every single time. And once I have that, really what I want to be doing is actually putting that into a unit test and just running like code against that test itself. And I have different ways of being systematic in my testing or my replication. I make heavy use of incognito mode in the browser. Okay, so the point of the incognito mode for me is that it has none of my logged in state, it has none of my cookies, it has none of the local storage, it has none of my extensions. The extensions actually play a part in the browser. All the extensions you have, when you run that page, affect that page's runtime. It can also introduce variables, and it can also override variables. Yeah, I've had real issues, real bugs where if you use window.name in your code, or you use a variable called name and a global scope, there are extensions that will make use of window.name or a variable .name. It clobbers the global scope, and it happens. So yeah, incognito mode to do those tests. And make use of multiple profiles. If you're doing a lot of testing and a lot of debugging, I've got my normal profile when I'm signed into Gmail and all the different systems I want to use because I want to actually use them as a consumer. But when I want to look at kind of a completely fresh view on a page and do kind of a series of tests, I can have another development user, for instance. And I even have a user that's set up to have everything disabled, like the security up to the max. All my cookies are disabled for that particular user. Certain things certain privacy is kind of raised to the highest level, and web pages behave differently. For instance, if you try and access local storage and the user has cookies disabled, some browsers will throw an exception. Okay, and you'll only see that by having this kind of strict mode. Now, I definitely don't recommend going all the way to this kind of extreme privacy mode right at the beginning. Kind of build your way up to it. But if you really can't replicate the bug, get this really, really clean environment, this really clean user, and see if you can see what your end user, the person reporting the bug, actually sees. So now that we can replicate the bug, we need to isolate it. Okay, and a lot of the time, a lot of the bugs that I encounter, the isolation part is kind of keeping the state of the application, like all the steps that it took to get to that point in time. But once I can capture it down to that one piece of code or that block, that's what I'm then working with. I can create a test case and so on. I built tools like JSBin to solve this particular problem. How do I isolate this one particular problem? Either a layout issue that people I used to work with years ago, or JavaScript issues. I was getting written emails in English telling me or describing to me in detail about bugs in code, and I would have to write back in written English what the answer was. So I built JSBin to basically have an isolated version of their bug, so I could just fix that piece and give it back to them. Now, this is kind of my backup for all isolation, is this 50-50 testing, where you've got a massive file of JavaScript and you don't know where the problem is, and you basically just slice it in half, get rid of one half, run the code with the leftover half, and if the bug is still there, then you know it's in that half, and you keep reducing it down. It's an awful way of debugging, but it works. But it's all about reducing and reducing and reducing, getting down to the smallest test cases possible. And the same goes for reporting bugs to browsers as well. They want this kind of very, very small test case. And once I've got that, it's the easy part, right? Eliminating the bug. I can't count the number of times, I can't remember the number of times where the bug was like, there was a full stop instead of a comma, or there was a missing semicolon, or there was a typo in something. The actual bug fix itself, for a lot of the time, so in my experience, has been a very small amount of work. It's all front-loaded and then replicating the bug, isolating it, and then just fixing it tends to be a very small piece. And again, we're talking about debugging, but hopefully this is where all the tests happen as well. You've written a test and you'll never see that bug again. So, replicate, isolate, and eliminate entirely. There are also other types of bugs that this doesn't work for. Heisenbug. This is a real thing. So a Heisenbug is one that changes when you try and look at it. So by debugging it, the bug changes. And I've had real experience of this kind of thing. This tends to happen with kind of hardware and kind of much more complex systems, but sometimes when I put some test cases into Travis, for instance, when it runs in continuous integration, Travis runs, the environment's slightly different. So the test now fails because it expected the environment to be however I tested in the first place. So my bug is no longer there, and my test fails because it's looking for something that isn't there, or the environment's different, so it fails the test. And going back in time, Firebug, now a finished project, but Firebug would introduce globals into your namespace, and it would affect rendering time, so it would affect actually debugging. If you had Firebug open, it could affect how you were debugging, and it would cause bugs in your code as you were trying to debug. A more modern version of that is basically, if you're doing like a performance profile on a website using the DevTools, if you have something like Spotify open or any other browser window that has a WebKit view in it, that will affect the rendering performance of that at that recording, for instance. Plus, it's Breaking Bad, so that's pretty cool, right? Okay. My one tip on this is if you are using DevTools, in the next talk you might kind of learn about some of the experiments. There are ways of turning on the experiments that are in DevTools. If you have them all turned on, for instance, that will affect your debugging tool, and it will and can cause bugs. So just be wary of that. Okay, so we have these three kind of arts of debugging, and this is really where I think that the crux and the most interesting part of debugging happens, in the state. A bug occurs because some state, the application has reached a certain state, and that bug happens. So most of what I'm trying to do is understand exactly how I got to that state. And without the state, I can't work out what's wrong, and if I lose all that state, then I've lost the ability to actually see the bug in the first place. So I kind of look at state in two different categories. So the first one is what I'm kind of referring to as passive state. Passive state is something that has happened, or it is in that state right now. So I can observe that state, and I can use that information to help me debug or replicate that particular problem. So examples of this are kind of the history of network requests that you have. You can have rendering histories for canvases, for instance, so you can cycle through those. Memory usage, and so on. What's a lot more interesting is interactive state, actually being able to go in and change the state in real time and see the effects of manipulating that state on the particular problem you're debugging. Okay, so I'm going to show you this in a bit, but this is why I love working with DevTools, and why for me it's kind of a massive leap forward from all the tools I've used over time. I can kind of see that passive state, and I can go into DevTools, change the state in real time, and I can see that changing that state causes the bug to be fixed, or changes the way the page is rendered, or returns different output from a function. So yeah, being able to interact with the actual state is really key to me. Yes, very powerful stuff. And then the second half of the state is actually the stack, how we got to that point in time. Now, this was the screenshot I had earlier. This is a stack trace from a transpiled error in React. I can't read this. I mean, I can read it, but I have no idea where the actual bug really lies. Source maps will get us some part of that, but being able to have a stack trace is incredibly important, because that's what leads me to a problem. So there's nothing that exists right now where you can take, I think, there's nothing that exists right now that can take like a complete snapshot of state and be able to kind of reuse that. But that's kind of where I hope we might get to, where we can just say, right, I have a bug on my machine, Sarah is the expert at this particular bug debugging process. I'm going to take a snapshot of everything I see, and she's going to load it up in DevTools and be able to get exactly back to that point. And she'll be able to work out in JavaScript and memory, in the network request, how I got to that particular bug, and she can fix it for me. That doesn't exist as far as I know. They're all developers, maybe. Someone could build that. That'd be cool. Okay, so There's all these different tools inside of DevTools that allow me to approach debugging in two different ways. So the first one I refer to as inside out. This is where I know exactly where the problem lives inside the source code. I have knowledge of the source code. I can start from inside of the source, and I can like set a breakpoint so that the code stops at that point. I can start interrogating memory, looking at what network requests took me to that point in time. I can use things like debugger, breakpoints, conditional breakpoints, and so on. Outside in is much more interesting. It's where you observe a bug in a page, but you have no idea what's causing it. You have no idea, like someone else is working on the code and you're working on your section. You don't know where to break the code. So there are a whole bunch of tools that help you say, okay, I see a bug that happens when I click on this thing, so I need you to stop the code at that point when I click on that thing, and let me go into the code and go looking for this particular bug. So this includes things like conditional breakpoint, DOM breakpoints, XHR breakpoints, replaying XHR, screenshots, and so on. So this is the inside out. So you have knowledge of the code in the first place, which, depending on the project, you might have a complete knowledge of all the code base. If you're working with other people in a team, you may not have complete knowledge of the entire code base. You've got debugger statements, your exposal, conditional breakpoints. You can look at, the variable scope, variable state in the scope, the different closures in scope, and you can use a console that is now in scope once I've paused the code to actually look around and look at the state of memory at that point. The outside in are things like right-clicking on DOM nodes and saying break as well. I can use screenshots to see that something is happening on a page where I know it looks wrong, and I can try and narrow down into the code that's actually running at that point in time, try and narrow down the amount of code I have to debug. And you can break on arbitrary events, such as the canvas is painted or XHR fires and so on. So I wanted to show you some of my favorites. And yes, I have favorite debugging tools. I should get out a lot more. So I'm going to switch to live coding, and this is totally going to work. Right, okay, so this is my super complex application that gives GIFs, okay? I will kill the GIFs eventually, because they just get really distracting. So, yeah, let's kill the GIFs, because that will just... How do I kill the GIFs? Oh. Alright. Yeah, hang on, give me 1 second while I kill some GIFs. Oh, maybe not. Okay, well they're going to play, but you won't be distracted, you're going to look over here, right? Okay, so, pretty much one of the first things I do with any project I'm working on is actually turn this from kind of an observation to looking at code and trying to set breakpoints and looking at the CSS to making it into a workspace. So at the moment, these are all read-only. The assets are being served over the wire, and what I want to do is make this code editable and savable. So if I make a change, I don't know, let's find some CSS. If I make a change to the body background color, right, it's dark. If I hit refresh, obviously it doesn't save, okay? So the first thing I'm going to do is open up my directory, which is super small, and just drag it into the sources panel. And I'm going to make a workspace. So this is going to ask me if if my browser should have the right access to that directory. I'm going to say, yep, go ahead. And you can see in my sources I have this new directory. Now, the current version of DevTools, I can manually put these together, but there is a new version. Oops. Sorry. If I go to Now, give it to my daughter. Yeah. The settings, I can go to a feature called Persistence 2.0. If I tick this and reload DevTools, what DevTools is going to try and do is take the directory structure that I just dropped into the sources panel and automatically match it up to my the assets that were served over the wire. And the way that I know it's worked, I get this little green dot. So I haven't had to do anything. All I did was drop the directory into my sources panel, hit, yep, I want you to be able to read this, and it's now worked out that the style sheet on my in this directory is the style sheet that I was serving over the wire. So now if I change this from white to, I don't know, hot pink, because we all love hot pink, I can save that. So I've got the little star up the top, I hit Command S, it's saved, hit refresh, and it's persisted to disk. Okay, straightforward. But what's much more interesting is in the JavaScript. Or straightforward, I think it's straightforward. So in the JavaScript, I talked about kind of in-memory changes. I'm going to set a breakpoint inside this code. So this is the code that gets me to animated GIFs. So I'm going to set a breakpoint here and hit the give me GIFs. And I don't feel like 2 GIFs is enough, right? We always need more GIFs. So I'm going to change it to 6 GIFs. As soon as I made that keystroke, it switched from kind of running code or paused code to completely broken edit mode. So the code's not running at all. I have the star up in the corner up here say it's unchanged. But importantly, when I hit Command S and save, this little function here, this one-line function is going to get recompiled and put back into memory. So I hit save, the cursor in memory is backed up a little bit to before that function was called. I'm going to hit play down here. And it's going to give me 6 GIFs. So this is really powerful for me. I can go in and pause the code, make my change, and the fact that it will recompile the memory and recompile the function and put it back into memory is really, really useful for debugging for me. So yeah, I mean, those are 2 actually very powerful features that we didn't have in debuggers for a long time. It's also worth pointing out this is synced with my editor as well. If I go over to VS Code, if I change this to red and hit save, it's updated here, but it's also updated in my DevTools, right? Because there was a link between the 2. Let's change it to black so you can see it a bit better. Black. I hit save. All I've done is hit save on my VS Code, and it's changed DevTools, and it's changed it in the browser as well. And that applies to JavaScript. I'm not sure if it's going to recompile the memory. I think it only recompiles to the other breakpoint, but it's useful if you'd rather use the editor. But then, you know, I quite like Code Mirror. It's pretty good. It has some really good features inside of it. I'm not going to kind of dig into lots of them. You'll see some of them in Next Talk as well. So, I use VS Code. I've come from Sublime. I'm a big fan of palettes for kind of navigation. So this thing, DevTools has the same thing. So I'm doing Command Shift P. Mac is slightly different keyboard shortcut. I think it's Control Shift P. And what I'm getting is a list of everything that I can do from DevTools. Right? So I can disable JavaScript from here, or I can re-enable it. Sorry, I've got 2 keyboards here. 2 keys here. 2 microphones here are making my hand a bit all over the place. One thing I do all the time is I undock the DevTools from the palette, right, and jump backwards and forwards between these 2 things. But from the palette as well, you can go to, you can use the same palette to navigate code as well. So where I'm doing Command Shift P, it's giving me this angle bracket, this little angle bracket here. If I change it to get rid of it, I get all the list of files, so I'm going to navigate the files. If I do an @ symbol, yeah, I can start navigating the symbols. So this gives me all the symbols in the CSS, but the same applies to JavaScript, right? So I mean, I only have one function here, but I can use it in much more complicated files. Like this really complicated file, whatever. So the palette works, I mean, if you're familiar with VS Code, the palette works exactly the same way. So angle bracket means functionality, at means symbols, and then you can navigate files and so on. One of the questions I get in my workshop as well is, I'm making these changes in the code. I'm changing these values. I can change my JavaScript. I can, it's a bug, yeah. I can go into the elements panel and remove parts. I can, move elements around. And one of the questions I get a lot of the time is, let's get rid of some of the animated GIFs because they're quite scary. There you go. One of the questions I get in the workshop is, I just made a bunch of changes, or you can do it from the dev tools, the picker down here, and it instantly changes the file on disk. And people are worried about those changes committing to disk and not wanting those. But you're using some kind of version control, right? So as a backup, you have version control. You also have undo inside the dev tools, right? I can do Command Z, and I can get all those divs back. I can get the H1 back, I can get all my CSS back. If I go to the sources panel, I can get all that CSS, all that JavaScript to revert back. I'm just using Command Z, and it's just undoing all the changes I did. So I can undo inside the DevTools. Now, if I was in Sublime, for instance, I made a bunch of changes, and I close Sublime and reopen it, I wouldn't expect it to be able to undo anymore, right? If I close DevTools and I reopen it, it can't undo the changes I made. So whilst DevTools is open, you can undo. But once you close it, your editor is gone. Okay, so there's a few bits around here as well. Like people ask about source maps and SAS and less, and so the answer to SAS and less is yes. The answer to Babel is no, and yeah, that will be solved one day. I talked about kind of outside in, so I want to show you. Let's get rid of these animated GIFs for a second. I want to talk about. Show you how I used screenshots to debug a problem in JSBin. So I recorded a video of this because it's an old version of a bug, so I didn't want to revert JSBin to be buggy. Basically, I noticed on JSBin that there was kind of this weird flashing in the editor. It would load, and then there would be a brief flash, and then it would load again. And it was very, very small. It was a very, very small amount of time. And I found it difficult to actually, I couldn't see anywhere in the code that made it obvious where the flash was coming from, and I also wasn't sure what was triggering it in the first place. So the first thing I did was open up the DevTools and go over to the Performance panel. But from there, I actually changed, I'm throttling the network. So if I undock this and go to network, from here, I can throttle, I can emulate a slow connection, right? So I changed JSBin to run over a regular 3G connection just to slow it down, to kind of get a slow motion idea of what was going on. And then I recorded with screenshots turned on. And from that, I was able to kind of move forward through time, and I could see that at this point, this is what I was seeing. Right? The JSBin was rendered, the code was there, and it would be rendered, and then it would disappear, and then it would reappear. Okay, so this gap is longer because I slowed down, basically. And what I was able to do from here is narrow down to this section in the timeline to be able to work out what was going on. Now, when I narrow this down, it becomes quite obvious that actually there's a network request going on for a font that was causing the flashing of text. Now, I've seen this enough times to know that that flashing just means the font is coming in, removing the text and put it back in again. When I first saw that, I had no idea why it was flashing. It seemed to completely render. Because I was able to slow down the rendering and look at those screenshots and narrow down what was going on over the network and in the JavaScript, I could see that network request was causing the problem. And by front loading that and putting it into local storage, I was able to completely get rid of it by using this kind of outside-in approach, by using screenshots to work out what's actually happening at that point. How am I doing for time? I kind of lost track. I think I've got 5 minutes.
Yeah, 5.
Yeah, 5 minutes? Yeah, cool. Okay, so there are loads and loads of tools. Like I said, these are some of my favorite things. The last one is memory leaks. So memory leaks. Being able to debug memory leaks is complicated. And actually, I ran FFConf 2 weeks ago, and we had a talk dedicated to memory leaks. So Katie's talk will be out on video in a week or so. But I'm going to show you how I'll debug memory leaks in 5 minutes. Okay. So this is a real game that I wrote a few years ago. And I watched a short Google video on how memory works in Chrome, and I thought I'd apply that same practice to this game. And through using that approach, I found that it had a real memory leak in it. And the key to, or I think that the key to approaching memory leaks is having a baseline to start with, right? So you refresh your page, you take a snapshot of what the memory looks like in the first place with like an idle version of your application, or it might be, when it gets up to that state, you take a snapshot of what your application looks like. And then you do the thing that causes, or you suspect causes that memory leak. And you do it a few times. You do it a systematic number of times. So I'm going to do a thing, like start the game 3 times systematically. And I'm going to take another snapshot. And what I then do is compare the snapshot I just took against my baseline. And that will tell me if there's any oddities, anything that I should be looking out for that might be a problem. I've already got kind of an idea that memory's leaking in this game, but it's unclear kind of where it's leaking. So I'm looking at this column here, deltas. So these are the number of elements that are or the number of bits of memory that are kind of like introduced between the first snapshot and the second snapshot. So I'm going to order by delta. This video I watched basically said anything in brackets you can ignore because they're part of the browser and you can't really control them. So I just learned to ignore everything in brackets. And memory debugging is really, it's kind of a detective process. You get to kind of get clues. You don't always get the answer in my experience, but you get all these different clues about what could be wrong. And one of the things here is there is this detached DOM tree. And there should be no detached DOM tree in my game. I wrote the game, there's a whole bunch of code, it's not super complicated, but there's definitely no leftover trees, like DOM trees laying around. So when I dig into this, I also see there's 147 of them, which is a factor of 3. And down here is what I'm looking for. This red block, this means that there's a JavaScript object that can't be tied up from regular garbage collection. So there's a leaking object in memory. So if it can't be garbage collected, it means that it's always in memory and it will keep consuming more and more memory and so on. And it will eventually it'll slow down the whole application basically. Now, my game's pretty small and it's possible people will hit refresh a lot, but if it's something like Gmail, you're looking for this kind of thing. You don't want memory to be leaking, or if you're building maybe like a holiday finding application, people can be on the same page, you can be searching through the results and windows are opening and closing and so on, you're using up memory, you want the garbage collection to kind of get rid of everything. So red elements is what I'm looking for, and inside of that red element I start getting clues about where this memory leak exists. So I don't get all the answers, but I get clues like there is a cache involved, there's something to do with a click handler, there's this responder function which I can click on and actually go to, and I know that this is causing the memory leak, but this is inside my JavaScript library, so it's not my user code at this point, it's kind of the equivalent to kind of dipping into jQuery or React or whatever library you're using. But these give me clues as to where the actual bug is going to be. And when I dig deeply enough into it, I'll find that the click handler, if I hover over it, has these functions, and this function here, select marble, is where this is my leaking function. This function has a reference back to this DOM node that can't be released, and there's something in there that's causing it to leak, effectively. So I'm just going to right-click, show function definition, it jumps straight to that code, and from there I should be able to look at like why is it leaking, what is it in the code that's causing it to leak, what sets this function in the first place. If I find that in the code base, I can see that it's attached here, so something in here is actually causing my memory leak. I'm not going to show you where the memory leak is, because like I said, it's clues. They're all clues leading you to a place. But there's something going on in this click handler, this function, and quite possibly this entire function init draw is causing a memory leak. And there's a fast version of this where you can do, go back to the profiles, you can do record allocation timer, which is basically just a real-time version of this. If I start and just click new game a bunch of times, if we have a look at the memory, these blue bars that are left, these are things that can't be released. This is memory that hasn't been cleaned up. So I can dig into there, and I should be able to see the same kind of thing. HTML DOM element, div element, and those red leaky DOM nodes are still appearing. So those tell me that there are memory leaks there. So those are some of my favorites. There is a ton of stuff in DevTools. There is no silver bullet. I haven't shown you anything with Firefox. You can do audio debugging if you're doing any audio in Firefox. Really useful for kind of seeing in real time those nodes kind of connecting and being able to turn them on and off. There's WebGL debuggers in Firefox as well, which I am frankly scared of. WebGL looks amazing, but I have no idea how to program it. IE has some unique tools, and there's also being able to connect like your VS Code to Chrome DevTools and doing real-time kind of breakpoints and so on. But there's so many tools out there. The point is to kind of get familiar with a lot of them and use the ones that work for you. So thank you for listening. I'm at the end, so you can ask me after the next talk if you have any questions. Thank you.